So this is the flip side of section point 5, and we're talking about compound and simple interest. Just a couple other concepts that I want to make sure that you're comfortable with from other math classes. So compound interest is in this section because of the exponentials that we just talked about. And if you have simple compound interest, that means that you have an amount of money that you're going to end up with at the end, an amount of money that you are investing, that's called P, an interest rate that you're getting for every period, depending on what the period is, and the number of periods of interest that you're going to get. So the formula looks like this. You take the amount of money you're investing, you add 1 to the interest rate, and then you continually multiply on that amount. So that will then compound your interest. So if you start out with $20,000 and you're getting an interest rate of 2%, 1 plus 0.02, when you multiply it by the $20,000, is going to raise you to the next level of money that you have. And then if you multiply it on again, you'll compound to the next level and to the next level. So this is how you think about it in terms of simple compound interest. But when you talk about multiple interest periods, this means that maybe the interest you're getting is monthly. And in that case, you would want to take your interest rate and divide it by 12, because the interest rate you're getting is going to be split into 12 pieces if it's coming monthly. And then that 12 that is being represented here by the letter M would get multiplied by the number of years that you invested, and that's the number of times it would compound. So your interest rate then would become a part of the annual interest rate, but then the number of times you compound would be more than the number of years that you have it. So the pieces to that puzzle are here. So an example would be, if you're investing $5,000, that would be your P, your principal. And if you're getting 8% per year, that would be your R. But when interest is compounded annually, that means that your M would be 1, and you'd be more in this top situation, where you wouldn't have to worry about breaking your interest up into pieces because it's compounded annually and you're getting this amount per year. So you would take your $5,000 and you would do 1 plus 0.08. And if you want to use this formula, these will actually end up being the same formula, because you would divide by 1, which doesn't really do anything, and then you take 1 times 3, which is the number of years. And so you're in effect just taking 1 plus the interest rate and raising it to the 3rd power. So this formula will cover all circumstances, whether the interest is compounded annually or semi-annually or monthly. But the way this is raising your amount of money, or increasing your amount of money, is you are multiplying by 1, which is keeping it steady, and multiplying by 0.08, which is raising it, and then adding those things together. So for the first year, you will have your $5,000 plus 8% more. And then you do that again. So this is after the first year. You're going to do that again. Take that amount of money. You'll have that amount of money, and you'll have 8% more. And then you'll do that one more time for the 3rd year. This will be your new amount of money for the 3rd year going into it. When you distribute it through, you'll have that amount of money plus 8% more. So the exponent just repeatedly multiplies on that multiplier that raises your money every year. If you are getting your interest quarterly, then it's going to change to however much money you invested. But now you've got to take your 6% per annum or per year and split it into 4 pieces. And then you're going to compound your money 8 times, because it's going to be 4 times a year for 2 years. and that's what the MT is doing. So if you multiply this out, it'll tell you how much money you have at the end. So I'm going to let you can do the multiplication on your calculator, check it on Canvas, make sure you're comfortable with that on your calculator. This is a little bit different kind of question. The zero coupon bond says they issue a bond, $200 bond, and the interest is coming monthly, which means M is 12, and the interest is accumulated until the bond reaches maturity. If after 5 years it's worth $500, they want to know what the interest rate was. So we're using the same formula, but what we know and what we don't know is a little different. We know that initially this bond was $200, and we know that now, after the accumulation of interest, it's $500. We know that the interest was calculated monthly, so that was 12 times a year. But we don't know what the interest rate was. That's the question. We know that the exponent should be 12 times 5 because it's compounded 60 times, 12 times a year for 5 years. So now we got to back into what the interest rate was. And so the algebra behind this is a little different. We're going to have to solve for R, and the way we solve for R is we're going to isolate the thing that's raised to the exponent. So we are going to take the 500 and divide away 200 to start, so that we can start isolating this thing. So we're going to divide both sides by 200. It's going to look like this. And now we're going to have to use a 60th root to get rid of this 60th power. So we're going to take the 60th root of this side and the 60th root of this side. And that's going to leave us with 1 plus r over 12. So to take the 60th root, I don't have my graphing calculator with me, but I do know that I can take the number 5 divided by 2, and then I can raise that to the 1 divided by 60th power, because that will allow me to do a 60th root, raising it to the 1 over 60. And so I get this 1.015388, this really long number that I am going to not approximate. I'm just going to leave it here in my cell phone calculator. And then I'm going to subtract 1 from it, and I'll get the decimal portion of it. And then I'm going to multiply by 12. And that's going to help me figure out my interest rate. So I've got my calculator back. There we go. So I got this number in here, and I'm subtracting 1 from it. And then I'm going to multiply it by 12. And I end up with 0.185 approximately, which means that it's about a 18.5% interest rate. So again, something you should have seen before in one of your math classes, how to solve something like that. I just wanted to do a quick review so that we were all on the same page with compound interest.